So today we're going to talk about Inferact,
Can
and
you say that
our
again?
scale and fail.
Can you say
What?
that again?
Inferact. I'm dropping the T. My New England accent's coming through. Who just raised $150 million seed round out of $800 million valuation. Pretty big round, especially for a seed, like we were just saying. And we have a new face with us, Andrew Pascoe, who is our new CTO for Market Genius AI, among doing many other projects. Super excited to have you joining us to talk on the tech side, Andrew.
Yeah. Thanks for having me, you guys.
I can't wait for you to explain to me what a vLLM is because as much as I did my research on it, I was like, it's going to be nice to have Andrew here. So, do you want to start by telling us a little bit about what Inferact does?
Yeah. Infrax is recently founded, and they really want to push forward like this open source project called vLLM. And basically, what vLLM is, it's an abstraction layer. It tries to say that, hey, depending on the models that you have or hardware you have, um, there's this kind of like layer that just allows things to kind of connect and just like make things easy for developers. And it's particularly focused on, open source models as well. That's kind of one of like the key points of the company. They really believe in open source overall. The founders of Inferact are uh, the original creators and maintainers of this open source library. And it's deployed all over the place. So pretty neat stuff. Obviously, like we'll have to like get into get into it more, but that's the overall view. It just kind of how do we make it easier to deploy more machine learning models in more places on more hardware.
Yeah. And so, how would someone use this? Like, if I'm an engineer, walk me through how I would use this.
Yeah, so, maybe I start out and, like, I actually wanna, like, experiment with open source models, right? And they're built with, like, all these, like, different architectures, you can, like, download them or whatever, try to get them running, but, I might be trying to run stuff on my local machine, I might be trying to run things on servers elsewhere, or I want to experiment with different types of servers, things like that. vLLM will kind of just take all of that complexity away and just kind of say like, look, I'm going to code like towards vLLM, and now I can kind of deploy these open source models like where I want. I can start to experiment. Now it's obviously like more than just experimenting. It also has like facilities. It has like these nice kind of
Mm.
API layers in order to be able to, do things with agents and kind of connect things. You can have like a model that sort of tries to like transcribe audio, and there's just an API. You just like ship over your audio stream, and basically all of this is like this kind of containerized, like deploy, scale up servers, figure out where the models like need to be loaded on these different servers, things like that. It really, really helps with these kind of like massive deployments.
Yeah,
Um, one of the things that they talk about too, it's like they expect that this year we're going to start to see multi-trillion parameter models.
which is
I mean,
insane.
these things, I mean, we're already at trillion parameter models, so
Yeah.
multi-trillion parameters. Um, they're gonna like those models can't all sit on one machine.
No.
So there's a whole bunch of how do you actually like get this stuff deployed? How do you make sure that like the parts of the models sitting in different servers is distributed in the best way possible to actually, try to keep your costs low and keep performance high.
Yep, that makes sense. Demetrius, anything to add?
No, I think think it's definitely a growth problem for a lot of companies that needs to be absorbed. I also see this from the financial perspective, and if you think about the capex and the massive investment that a lot of these large companies made, the optimization of utilization of the GPU that this technology is offering is critical, right? So the way I understand this is like, okay, for um, you know, 20% of capacity used on the GPU requires a certain percentage of backup that needs to be maintained because that's how the large language model works today. So that means that the effectiveness for every dollar they're spending on capex is just much lower than using this with this technology that is optimizing that work. So,
that makes a lot of sense. For every buck you're spending, you're making more money, in capex, right? So I think it's a pretty fundamental shift when it comes to the growth that is anticipated on the market and how these companies will host that the growth in their infrastructure.
Yeah, absolutely. Do we wanna chat I think the founding story is interesting, but do we wanna chat about founders and investors first?
Uh,
Uh, how about founders? Let's talk about the
Let's
founders.
let's do it. So a lot of them are coming from, UC Berkeley's Sky Computing Lab, which is pretty interesting. It's basically like their infrastructure AI lab that they house, and so let's see, I'm looking at it. So 2 are from that, and then they have, academics and, the founders of the lab, helping as well. So you have a CEO, Simon Moe. Uh, did either of you find anything interesting on his background?
I mean, I like he's primary. Yeah, he's got a PhD in computer science from UC Berkeley. Worked with Wusik, another founder that I'm sure we'll talk about. But yeah, I mean that's kind of what I dug into. Like obviously, like in the computer science lab, like working on machine learning problems and things like that.
Yeah, and so Wusek is from, the lab as well, and part of that team does design this. And then there's 2 other co-founders that are core contributors, so I'm gonna butcher this name. Andrew, you got this one? Ka Kao Ka
Kai Chao
there
Yu,
you
Kai
go.
Chao Yu. I'm guessing.
Yes,
Yep.
yes. And so there's, from China and has that lens on the project as well, which will be interesting. And then Roger Wang, who is, a maintainer and really focus on the systems of what they're doing. So pretty strong team. Will be interesting from a global perspective. I think having those Chinese roots is going to be helpful for them to expand as well.
yeah,
Any other
I think
thoughts?
that the team is much larger, right? There are other key founders. You
Oh yeah.
mentioned Roger Wang, Joseph Gonzalez, and Ian Stoica. Um,
Yeah, they're they're the professors, that are coming in and part of this
right. Not
founding team
only,
as
not
well,
only
and
they are
advisors. Yeah.
partially
Yep.
advocating on behalf of this company,
Yeah. Yep.
especially Ian. He was a co-founder of Databricks and Anyscale, and that is adding, I think, a lot of legitimacy behind the business, whether this is really commercially viable idea. Assuming these uh, venture capital, they just see this and they say, "Hey, there is a playbook. Somebody saw that. Somebody invested time to understand, can connect this with the market conditions and where the market is going, especially for someone who's coming from a kind of this environment, and was pretty successful, right? Databricks is, you know, objectively a success story, so it makes a lot of sense. Um, yeah,
Yeah, he's bringing the
Yeah,
experience, and he also has Spark and Ray as infra startups, as well. Go ahead, Andrew.
yeah. Well, I was gonna say, I think it was like Wusik actually kind of got this started. He had some time on a break and was trying to play with like this open source model that had come out. It was like OPT, and this is back in 2022. This is before the whole like GPT thing, and he was just trying to like get it to make predictions or inference, right? Thus Inferact. And he was like, "Oh, I bet I could optimize this." And he started playing with it, and he tried to get Simon involved. And I guess Simon kind of put it off for a little while until he got involved. And they're kind of saying like at the time, he was like, "I'm not sure like inference is even like that interesting of a problem, right?" It's like,
It
well,
might have
like
not
building
been
them.
then, right?
What's that?
It might have not been then, right? Like, we didn't have the quite the scale?
Uh, no, I understand, like, maybe as, like, a researcher, you're like, "Whatever." Like,
Yeah.
after I've like, how do you train the model? And then it's like right, and then the inference part's like, well, how well does the model work? Right? It's like, how's it doing predictions? How's it coming up with that next token or, like, whatever it is? And so, I can kinda understand, within, like, a CS lab, you might say, "Well, the fun stuff is actually, like, on the training and, like, building the models." Like, what's like the overall network like or something, the network structure or whatever. But and kind of digging in and just trying to optimize the inference side of things, like, well, yeah, but like that might not be like super important for papers. But I mean, in production environments, that's like very, very important. I mean, these are things that like I've worried about a lot for like a long time. Like, uh, you know, how quickly can you respond to like a request to make a prediction? That's like it's particularly important in the ads space, right? So, but as you kinda get into it, you might even think like, well, inference itself, it's like whatever, like, you know, to be better with your memory management, be better with your, like your CPU caches or things like that. But kind of like really what they kind of discovered is, okay, all of a sudden, like there's this glut of like new open source models coming out with like, uh, different network types and things like that, the different neural network types. And all of a sudden it's like, whoa, like how do you actually, like, make all of these things efficient on all these, like, different, like, deployment scenarios? As I said, you have local machines to, like, these really beefy NVIDIA GPUs or AMD GPUs or Google TPUs, tensor processing units, right? And so, really, like, as they just kinda added more and more, um, they realized that the optimization problems are interesting academically in and of themselves. But yeah, I mean, like, it's kinda neat. Like, they started in a lab working on like a side project just to, like, make something a little bit better, a little bit more efficient, and then, they just
Scaled.
keep, like, building things into it, get more open source contributors. I think it's, like, over 2,000 contributors right now, and their software is, like, running on top of an estimated, like, 400,000 GPUs globally. It's pretty
Wow.
good.
Yeah. Yeah,
Right.
they definitely have traction. Thus probably the big seed round, I would assume. Let's talk a little bit about the investors. So you have A16Z, who when we're talking about like AI, Infrabets, they've invested in OpenAI, 11 Labs, Cursor, Lightspeed Ventures Partners, who actually has a formal venture partnership with Berkeley Sky Computing Labs, and they've done Anthropic, Databricks, and you have Sequoia Capital, Hugging Face, Harvey, Streamlit, Altimeter Capital, NVIDIA, Hammerspace, Snowflake, Redpoint Ventures, and then Zen Fund, which is a China US seed fund. And so they've been an early backer of many Chinese tech and AI founders. So, and there's more too. Those are like the bigger investors there. A lot of those are very familiar names if you work in the tech space, but like heavy hitting investor lists for them.
Yeah, I think for that type of round, you need to have a few, right? You won't have a one that is just giving you 150 million, check. I mean, it validates what are the current market conditions, in my opinion, right? If you think about this in 2025, um, we had probably roughly 18% of these 100 plus million investments, mega rounds. But those were representing around 50% of the value of the investments. So you can really drive a lot of conclusions from this, but one of them would be, the AI is attracting a lot of large funds, and then most likely will invest in something that is fundamentally shifting the market. Usually, infrastructure type of investments, at the expense of other companies that are struggling to get the funding, right? So
Yeah.
that's definitely a kind of a market condition if it's the number of investors that are just chipping in something that is really looking good.
Yeah, it's definitely a conviction round. I mean, it's pretty clear they're like, okay, we see tractions here. We believe in vLLM. We think this is going to be billions, if not, trillion-dollar layer that is going to be created here, in my opinion. Any other investor? I know like Databricks Ventures is on there. That's always interesting for my exit strategy. Any other investors that piqued your interest?
I think there's one UC Berkeley Chancellor Fund. I will
Oh yeah, Berkeley backed it
Yeah,
too.
I mean, I feel like this is like a more of the courtesy of these other investors. Like, okay, yeah, it happened here. Maybe let's bring you in. Looks
Yeah.
like right because it's not at least to my knowledge, it's not a well known fund. At least in
Yeah, but it probably my assumption there is it would help them actually continue to build labs like this, right? So, like, if they can make some bets on companies, make some money from it,
yeah,
and then invest it back into labs, it's a pretty
no,
cool
it makes a lot
concept.
of sense, right? Like, yeah, of course, you know they want to continue bringing more of these ideas that these guys came up with, right? That's where they started. So I'm glad that actually they brought him in, and they have a skin in the game because, like you said, right, it's going to continue encouraging other entrepreneurs to just to do the same thing. But yeah, that's the only one outlier that I would probably call out besides the Databricks Ventures, which of course is coming from the one of the founding team members.
Yeah, yeah, yeah. What do we think they're gonna do with this money?
I mean,
Scale rapidly?
I mean, well, I think that they're gonna hire a lot of, like, a
Yeah.
decent number of people. They also need a certain amount of runway. And another thing that's important is, hey, like, new model comes out, new giant model. Um, you gotta test it. You gotta, like, test your code. You have to, like, put up a bunch of servers, like, actually like, hammer on it with, like, some, like, real inference, figure out how to, like, distribute this stuff. I think Simon said something like, "Oh, they're expecting." Yeah, they'll easily burn, like, millions of dollars a year just testing.
Testing.
Right, because, I mean, when you're talking about, like, this being, like, this abstraction layer, and to be clear, it's being used by, like, big companies right now, right? Like, LinkedIn uses it, like, Amazon uses it as, like, their layer for Rufus.
Mhm.
Um, you don't wanna be deploying stuff that could just fundamentally, like, break everything overnight, for, like, these major players, right? You need to, like testing's critical. Um but, I was surprised apparently, like, some of these big companies are deploying things even, like, when they're basically just pull requests, like, not even merged in just because they wanna get at the latest features sometimes. So, I think you'll also see kind of a little bit of that as well, like, certain companies willing to take, like, bigger risks or just kinda trying to be, like, at doing the latest stuff that they possibly can. But once you actually have something that's actually, like, out in production and people are relying on it, consistency and safety is pretty important.
Yeah, I would add here that putting my go-to-market hat for a moment, right? I think the technology is not following this typical AI notion that is trying to solve for intelligence problem. Is really trying to solve the efficiency problem. So by virtue is just targeting these large companies, large enterprise businesses that heavily invested in infrastructure. So in order to prove the value, you need to have a certain scale. So it's leaning towards that. To Andrew's point, it has to work, right? Because the large companies like this, they can't afford having some shitty service or support suddenly. And then the customers, millions of customers will start noticing something is off, right? That's just a reputation that they can't um, um,
Afford.
afford, right? So anyway, so I think it's a definitely an enterprise game. For that, you need to have a massive infrastructure. You need to have a lot of testing preparation, and also build some entire implementation process, right? That's heavy.
Yeah, let's talk a little bit about the go-to-market motion. They have some enterprises already using it, which is helpful. That's going to need to be part of it is enterprise sales. I also think there's probably an ecosystem play here, right? Like partnering up and getting customers either through model or hardware partners. And then the open source nature of it, right? Like it's a place where people can go and test. So hopefully, not a heavy need for sales people initially, but eventually, there will be some need for that. What are do you guys have other thoughts on that? Do you think the ecosystem model will work well for them?
Uh,
Like,
I
developers like to find things on their own.
yeah, but I mean, also when something becomes sufficiently standard and in particular, when you're trying to hire people and they already know the thing that you're using, like, there are
It's
definitely,
helpful.
like, these kinda, like, nice, like, lock-in network effects. Yeah, I mean, you know, I kinda gravitated towards this because of the technology and, like, and the problems that they're trying to solve, which I think are fundamentally pretty difficult. Um, but in terms of go-to-market, yeah, I was kinda wondering, it's like, okay, so how are they gonna make money? What is their actual model?
Yep.
And there are plenty of, like, examples of big open source stuff that garner lots of donations from companies that rely on it to kinda keep, like the Linux Foundation, right? It's like Linux is super, super important, and it's a nonprofit, right? And in some senses, like, well, it's a business, but it's and they spend time trying to, like, raise money and, like, actually get things done, but it's can be, like, really, really hard to just sell open source software. Like, uh, at least, free, you know, uh, free as in freedom, not free as in beer. Software. Um, and so, yeah, and then, sort of like another play is, okay, but we do lots of support. Right. So, yeah, like, we're actually a business. We sell kind of, some, like, high level, like, enterprise services for, the folks that are using our platform. It maybe provide some additional features, some closed source features on top of the open source stuff, to make it, I don't know, more copacetic for whatever an enterprise needs or whatever. But yeah, I don't know. The way that they're talking sounds more on the kind of foundation style of things to me, but, I'm not sure. I couldn't really get a good answer on that.
Yeah, what I kind of I was like digging and trying to figure it out. It looks like they do plan to have a paid serverless version of a vLLM. So that'd be one method that they could do. I think you nailed it with the enterprise features. It could be, onboarding support, integration support, SLAs. They could have monitoring, performance tuning. There's different things that they could do there with enterprise customers. And then I think there's an interesting play with strategic alliances with cloud providers and system integrators, right? So could they basically cut a rev share from those providers? Those are kind of that's why, I think the ecosystem led approach is going to probably be the easiest money to make if they do it right. The other ones are going to take some real go to market chops to be able to go and do that.
Yeah, there's another angle I think they can take, working with AMD and Intel to ramp up their kind of chips, competitiveness against the NVIDIA. Today, NVIDIA is the dominant player. If they go this route, they're definitely gonna enable more companies to compete with the NVIDIA. And arguably, the GPU cost for a lot of these companies trying to scale might come down. So that's definitely one a viable option they have. I don't know how long this would last, because there's a limited number of companies that are actually producing those chips at that scale. But arguably, the prices that companies paying right now for Nvidia, maybe are premium, very likely are. So coming down on that front, I think would give them a good position to have a strong start. Now, I think on the pricing side, I was thinking they're probably going to start with some community approach and then conversion to the enterprise. You're scaling your GPUs from, let's say, 10 to 1,000. Well, there you go, right? You layer this with a lot of additional support, enterprise support, call it, and that's how you start making money. Because the core infrastructure is out there, right? A lot of companies have a GPUs. They're already using AI or the AI provider on some kind. It's just a question how they can infuse the efficiency behind that infrastructure. So the more the users, the more of these GPUs are um, in the enterprise space, the more the validity of the offer and therefore conversion exists. So yeah.
Yeah. Let's talk a little bit about the risks they have, or they're up against. Andrew, you mentioned it's a hard problem to solve technically. So do you think that's a risk that they may face there?
Uh, yeah. I mean, it's because there's just so much stuff going on, right? Um, that trying to keep up with all of the latest things that are being released and all the, advancements in hardware, any type of like interface change, tomorrow someone announces some new type of model that's great and it's just they got to get cracking, right? To actually make it compatible with all these things. Now, I think that's part of what they're trying to solve is to try to become such a base layer that no one would even think about like releasing a model that isn't VLLM compatible, right?
Yes.
Um,
That's
but
where they have to get to, right? Like, it's a non-starter
yeah,
to not be compatible, so these models will go and
right.
work with them.
But once you're kind of in like the research space, it's like, well, something really good might not fit your current model or the way that like you're thinking about the problem. So there's some risk there. I think another one of their big risks is, I mean, a lot of models now are closed source. Right? Um, I love open source stuff, but when you have like these companies investing however many billions to or across the industry trillions of dollars building data centers to train their own private models. Maybe those things are deployed on vLLM, maybe they're not, right? Maybe there's some proprietary way that you've done this investment already training it. Like we might as well invest in kind of our own solution for inference deployment. Um, and it's possible that there are just like these kind of like dominant private models, and VLM I think can still be important. For research and that kind of openness, the people who want to know exactly what it is they're using and build it for themselves. I love that attitude, but sometimes
The way the market
that's
goes.
not always like the dominant flow, right? Um, but yeah.
Any other risks?
I mean, there's a lot of risk when you are trying to create your own category, and that's what it is right now. Because um, to Andrew's point, there's a lot of things going on at the same time. I don't think sometimes these companies realizing that there's somebody else is working on the same in the same space or working on something that will be in the same space because it's so fast. So I see this more as a kind of this, remember HubSpot case? Oh, you don't fit anywhere in the Forrester, categories or Magic Quadrant, whatever. And it was just for a long time, it was not fitting anywhere until it just emerged a new category of the CRM. And here is a little bit similar. It's just the difference is that it's on steroids, essentially. It accelerates so fast that you don't know where it's going to go. So the type of competitors that they facing are already in the space, but they are not necessarily committing because they don't know where it's going to go. Then you have these large players like Andrew mentioned, and I think I agree with this. This is the largest probably group of real competitors because they have everything they need in order to compete. Right? They have um, they have resources, so they have a capital. They have a knowledge, they have infrastructure, most importantly, they have a lot of customers. So, it's gonna be hard to drag all these customers from these large players, um, and move them into something else, right? It has to be gradually probably tested with some in the mixed infrastructure until somebody will decide, okay, they're so good that we can't keep up with them. And, for that reason, they're going to be our preferred vendor. It takes time. That takes time, and like with anything selling to enterprise. So yes, this is the biggest competitor. Is almost the category on its own. So I see the risk on these three angles, right? The large enterprise players and creating their own category. You have to prove that there is a one category, and you don't have a lot of other players that are in the same space taking the same approach.
Well, no, and I mean, that's, like, kind of inherent when you create an open source model. Ideally, you won't have other open source competitors, and this model will be the one that people contribute to and want to go into. That's not always the case, but um, that is an option. Let's talk about competitors for a minute. NVIDIA has Tensor RT-LLM, right? Hugging Face has their own TGI. And then there's a bunch of, like, hosted inference platforms as well. NVIDIA is probably the biggest potential competitor. Um, what do you 2 think in terms of competitors and who's gonna be their biggest hurdle or if others will come up?
I mean, I'd probably be most concerned about just like cloud platforms, providing their own solutions. Once again, like these huge amounts of resources, as Demetrius was saying. But you
The
know,
hope would be that maybe one of those cloud platforms would buy them, right? Instead of creating
yeah,
their own?
yeah. I mean, that's possible. And that that's like a totally reasonable exit, right? But all that work that you put in is still open sourced. So, um, I guess like fingers crossed would be a buyer who still wanted to kind of contribute to the open nature of it, and they might have like their own enterprise things to put on top. But yeah, I would probably be most concerned about like the cloud platforms, and I guess like I didn't look at like the license, the vLLM repo, but it's also possible that platform it might be possible without having read the license that, hey, they basically, like, fork it internally, they do a lot of improvements on themselves, and it's like their paid for service is just better than anything else you can get, including from, like, the original open source repo.
Yeah, I think the biggest player among these web cloud services is Google, in my opinion. Not because they already are there. I think it's because the approach they're taking, usually building their infrastructure, building the solutions, they tend to be in their own silo. They're trying to have everything that is on, their own. It's almost similar to Apple when they started to work on their own chips, right? They started to build their own kind of hardware end to end, and ensure that this is almost like a closed system that they design, they execute, they run. And similar is with Google. So I'll I'll say this. It's probably a prediction. Um, it, the depending on how well Google will do on this depends the success of this company. Because if Google will have alternative and will build this quickly and will be able to compete, they're going to have a much harder time to scale this, across the all three major platforms. And very likely they will start with probably Amazon because they have a marketplace that is really working well.
Yep.
Um, Google Cloud is having their own marketplace, but they are having a slightly different approach. Like I said, Microsoft, in my opinion, is more somewhere between these two approaches. So I feel like they could win some, not necessarily full, but um, yes, they are very much changed into kind of how quickly Google will turn this into their own product and their own offering. If they really have it, they're gonna probably start accelerating because they're gonna be a viable competitor with the two other players that are out there.
So you think the faster Google creates it, the better
Yeah,
off
because their
for
adoption
them?
will.
Because then
Yes.
Amazon needs to catch up, and so does
Yes,
Microsoft.
and the
Yep.
two other players also heavily invested, like I said, in capex. So they definitely want to have the unit economics on their side, right? They will need to have something that will help to optimize the work of these GPUs. And for every dollar they're spending, these are publicly traded companies, so investors will pay a lot of attention. There's a lot of eyes on this. There'll be a lot of comments. People will ask questions. And once Google comes up with that optimization play, everyone will ask about it. And if the margins are not, if there's not enough signal on the market and on the street that the two other players actually have a room here to expand the margin, they they will have a hard time, right? But if everybody's on the same boat, it's much harder to make that play. So it's yeah, you have to have a competitor in order to prove that you are actually a viable business. That's kind of how I would define this.
Yeah. Yep, that makes sense. Well, to be determined how quickly Google does
Pretty much.
this. All right, let's get nerdy and talk about the technical side. I know this is where Andrew wants to dig in. So kind of what's like the foundational tech that they have, and then what differentiates the tech they have or the moat that they have?
Yeah, well, they're solving an N by M problem, right? As I said, like you got N models, M platforms, I got N times N things to try to solve. So I think technically there's just okay, like the strategy play of just that abstraction of being able to do whatever you want wherever you want. Uh And that, it might not sound like deeply technical, but that's one of the hard problems that I was kind of getting at earlier. It's especially when everything's changing underneath you. But then the other side of it is really, I think it's about this sort of okay, so if we talk about inference, right? You've trained your model, you spent your $1 trillion to train your model or whatever. Uh, and the way these guys put it, I think is exactly right. It's like, okay, you've invested all this money building the model. But there's no value in that. There's no value in having a model until you actually start to do inference on it, because you actually want the model to do things. It's like you need to use it. And so, okay, so you've spent this tons of money, so you need tons of users, right, to get the value out of it. So how are you gonna do this efficiently? Like, you have, like, this giant model. It won't sit on one server. So you can't even necessarily just, like, deploy it, like, completely horizontally and say, like, do, like, some load balancing. It's like, "Hey, like, all these different requests are coming in. I'm just gonna send it to this one model." But even that or, like, this one instance of the model. But even that isn't necessarily, like, the most efficient thing to do, right? So, when you're kind of dealing with these models, it's like, okay, like, how are you dividing up the memory? How are you making sure that when you take a request and tokenize it, or, if it's a different type of model, however you're thinking about your tokens, it's like, how do you make sure that you actually kinda cluster requests together such that maybe you're actually getting, like, the same type of stuff out of, like, the same kind of places, and really, like, maximizing, like, your utilization on your hardware layer, is like Demetrius was saying. You don't want your GPUs, like, sitting there just being, like, 80% idle. And so, really, like, that sort of, like, the memory management, like, the sort of, like, optimization of, like, the deployment layer of, like, where, like, the different memory's sitting, essentially, like, caching, like, what's actually, like, coming in, how can we just, like, repeat stuff rather than maybe necessarily, like, recomputing it, you know? And then also batching, like, how do you take things that are kinda, like, similar and, like, effectively, like, use that caching to your best advantage? So, once again, like, from like a real technical standpoint, like kind of looking at just this, like, in a space where your model is being, you're getting the value out of it and tons of people are using it. And you're getting all these requests coming from all these different places. And you want to make sure your really expensive hardware is being, like, used the best, and, like, everything's, like, being kind of put together correctly, sent to the right places, getting things back out as quickly as possible if you even need to compute, and, like, making sure you're not getting too many cache misses. That stuff is really, really complex. Like, I wouldn't, if there are, like, 10 really hard problems, and all those things that I just listed, and it ensures that actually they'll always have something to work on. They'll never be done. Um, because there's always, like, something new. This is actually mathematically true for kicks. There's this thing called the no free lunch theorem. It's, like, impossible to come up with an optimization scheme that works for every single problem. There's always some other optimization that would be better potentially for, like, a newly posed problem. And so, as, like, all these new models are coming out, new hardware is coming out, like, new servers, new capabilities, they've got, like, this huge runway of, like, really, really interesting problems that they can really, get into the weeds on. So, yeah.
It sounds complex. You said it might not sound like a challenging problem to solve, but it sounds very complex.
Yeah, yeah, when you get deep into it, it's, yeah, I mean, it's not, as Demetra said, it's not necessarily what you think of as, like, your typical, like, machine learning stuff.
Yeah.
Um, this is about infrastructure and efficiency, um, but the machine learning is interesting mathematically and from an engineering perspective, but, optimization is as well.
Yeah, we've
Um
talked a lot about optimization from a cost perspective. I think optimization from a speed perspective matters quite a bit too, depending on what the end solution is that's servicing. Like ultimately, that at the end somewhere there is probably a user that is expecting something to happen quickly. And if that that has users patience, whether it's a B2B use case or B2C use case, because it's only gotten shorter and shorter in terms of, like, what they expect the results to be, and as someone who, uses not highly complex AI models, but uses AI models, it's not great sometimes, like, AI is still kind of slow, and so this is, that's gonna be important as well for people to continue to adopt it. Um, Anything else from a technical lens, though?
No, I think there are a
Andrew, you
couple
did
of
a
good
good
examples we're
overview.
talking about, but I can't speak to all this magic that is happening with the machine learning, but I can definitely speak about
It is magic.
how this speaks to me on the efficiency side, right? Because yeah, if I can cut the magnitude of this is I think something important we should talk about, right? Like in some of these examples that I was exploring, I noticed that you can cut the number of GPUs um, needed to perform tasks by 50%. That's huge. That's huge, right? So to your point about the speed is still there with the 50% of the capacity needed for this, right?
Yeah.
Um, the capacity is also going up, from 3 to 5 times, in terms of the traffic. So you can accommodate with the 50% less more of that traffic. I mean, the efficiencies are just kind of stacking up with the approach that this technology offers, right? And you can just peak maybe with a 60,000 requests per day on the very limited number or budget, right? So that's like that's huge, right? So we're not talking about I would call, I don't know if this is really a term, something that is a sequential, efficiency here, right? That you're eliminating a step in the process. That it's a typical approach, right? You have a multi-dimensional, you have a horizontal and sequential because a lot of that stuff is just getting compressed, and some of the steps are being eliminated at the same time. And then you can do a lot of things in parallel, so that it's just completely different animal, right? The way this operates is just giving you these numbers because yes, you're looking for efficiencies in different way that we used to. So I'm looking at this from this perspective, and that is impressive to me, um, because that quickly translates into how I would model out the financials, and how I start modeling planning around this. Right. So just to add that.
Yeah, what's coming to my mind is, not understanding all the machine learning magic, but, Andrew showed me like how does an ad bidder make decisions, right? And we get hundreds of millions of requests a day. It's like hundreds of things that happen in milliseconds, right? And now we're talking about, and that was, predictive. Now we're talking about completely new models and all the things that need to happen there. Is that a good mindset for me to have, Andrew, of, like, thinking about the complexity of what these models are trying to compute?
Yeah, I think that's, like, about right, obviously, like, in a bidding scenario, it's like, well, we have, like, an auction, like, the page is, like, loading,
There's
there's only, like, so much.
parameters. Yeah, yeah.
Right, there's only so much time to get back, right? And, um, your time budget and your efficiency matters, right? Like, the faster you are, the more things you can consider, right? Or, like, the more time you have to compute, which means more complex your model could be, or like whatever kind of like auction theory things you want to do, like whatever it is, or the more data you want to grab to kind of feed into your inference. So yeah, I mean, when I was saying earlier, like I used to think about like inference speed and efficiency a lot. In ads, it's exactly like that. But this is the same type of problem, right? Um, you know, all the machine learning magic. I guess like maybe I'm just jaded. I don't know. It's not that magical to me. Like, yep, it's a bunch of math and it's just like a bunch of numbers, whatever. It's just bigger, right? There are fancier ideas in there. Don't get me wrong, but fundamentally, you know, like under the hood for like most of like this kind of stuff. If we're talking about LLMs, right? Or the chats or whatever. It's like under the hood, it's basically saying like, I've seen these words. What do I think the next word's gonna be? Like that's what it is. Uh, I hopefully it doesn't ruin the magic too much. But like the faster you can do that, uh, the more words you can output with the same hardware. And that's like where you're getting like these efficiencies, or you have like this many more users and I can support them. Or I can have bigger models, right? It's like once you start to like gain efficiency, I mean, it's like gaining money, right? It's like, oh, I saved some money. What do I want to spend it on? And there are like any number of things you can do to try to make your product better, by actually like gaining this efficiency.
Yeah, yeah, absolutely. And from a technical lens on their moat, to me, it's the ecosystem. They have 500 plus models, they have 200 plus chips, they have a contributor network. Like that is, yes, Google can go and build this for their own tech, I guess, and potentially beyond that. But right now, this seems to be a pretty clear moat for them. Um, what other, technical, probably some IP on like the optimizations themselves. Um, what other things do they have?
Well, I don't know about like the IP because it's open source, right?
Fair.
um, I I mean, like, you can't just, like, straight up take the code and do whatever you want with it, like, depending on the license, but, um, yeah, those things are kind of available to folks.
Yeah.
But I think, you know, like, listening to the founders talk, they explicitly wanted to be open source. I think they probably thought a little bit about this. It's like, how much are we giving away versus, how much do we wanna keep for ourselves? But, you know, they make a case, and I think it plays out different ways for different use cases. But traditionally, like for big deployment things, open source tends to be a little bit better at trying to get more ideas and more creative output into the world. And so you solve big things potentially faster than if even if you have like a bunch of resources and you're like a big company and you're just like you're dedicated to like this one thing, you're still trying to figure out how to monetize it, like all that stuff. And once again, to make this sort of like comparison to Linux, right? Like if vLLM is sort of this operating system layer for lots of different types of models and lots of different hardware, right? If you think about like what your operating system is doing at any given time, it's figuring out all the memory, it's figuring out all the processes that need to run. It has like all this sort of like prioritization stuff, like so that like your mouse doesn't get really slow when you're backing up your files or something like that, right? It's like if VLM can kind of like wedge itself in there and kind of become like this thing, and they have like lots of these contributors, I think that there is like this kind of case to be made that hey, they'll continue to have like lots and lots of creative solutions, and because the open source stuff is evolving so quickly with all these new models coming out, that anyone who's trying to hide it and keep it to themselves is going to this is from the founder's own words. They're the ones who are gonna end up behind,
Yeah. They can't execute
right?
as quickly.
Right. It's just there's too much going on. You need like tons of people to contribute to like get it done. Um, and it's not just about money. uh, It's about people's effort and how many people wanna collaborate and find the new stuff, you know? So
Yeah, I think they follow the Databricks playbook. You know, they started as open source as well.
Shocker.
Right, right, and then, yeah. So they I think we could define this as a kind of open core, where they launched this, right? A lot of people that were behind the Databricks, they were behind the Apache, Spark as well, which is the largest big data processing, right, tool at some point, open source engine for big data processing. So, that was that's already proven. They know this model. They know how to play this. They know the triggers. They know, that at some point this need to just uh, eh, kind of pain management kind of model, right? So you have all these people using this because they now consider this to be a standard, but there's something more you can offer, and that's how you start monetizing this, right? So I talked about this scaling element that could be one of the triggers, but it could be many more, right? And then I think you're moving at some point to kind of the third phase of this development where you're building some secret sauce based on that, and that's where you start scaling this on a kind of unprecedented scale, percentage growth. So that's how I see this. So I'm not really surprised that they started with the open source. However, I think you're touching a very important element of skills that are required behind this. So the first phase, I'm connecting exactly with that. I think to implement the vLLM model, you need to have a quite unique skill set. They are not in abundance right now on the market. You need to have someone who understands the AI very well and understands also the hardware. And just to be clear, a lot of engineers that were out there, they are not accustomed to deal with the hardware at the same, I would say, scale as last in the last 15, 20 years as the software was taking over the entire market, right? So I think we're going back to basics, and you need to have these two skill set, which, like I said, they're not. There's not a lot of that. So it will take a moment before they gonna become a standard, having enough people and saturate the market with those skill sets, moving to the next phase.
yeah, I think we were actually kind of talking about a couple different things. I think that yeah, they can totally go down like this sort of part of part of it's like proprietary and be able to sell that to enterprises with like all these,
Add-on
benefits. Or
features
like
or
this was
whatever.
like the Docker and like Databricks models.
Yeah.
But when I kind of talk about like speed of development and the open source stuff, that's more applied to like this like n times m problem, right? It's like someone builds an open source model, and if they build it against like vLLM or like use the APIs, make it vLLM compatible, they don't need to worry about the hardware side, right? And it's like, cool, like it's just out there. Or you're a developer, for some reason you've got like some hardware that is not supported by vLLM, or you're a hardware company and you want it to be, right? And it's like, okay, I'm gonna like put in the support for our hardware on like the other side of it, right? So you don't need like a developer that needs to necessarily be able to do both of those things. Um, and I think that because it's open source and because people, there's this is not a guarantee, but there's like a decent chance that enough people will kind of like bang on it that like they solve that like N by M problem better than any private company can do. But in terms of like the enterprise stuff, yeah, like the enterprises might be able to do way, way better for their specific use cases and their specific needs.
Yeah.
And that's why, I think it's like, this is called scale or fail. Well, listen, I know that's the question at the end, so I'm not going to give it away, but I don't, I'm on the fence. I'm on the fence. It really depends like on how these different aspects play out and
Yeah.
what they intend to do with the company based on those,
Yeah.
based on those certain aspects.
Just to we'll get to prediction time, but so what I'm hearing is Inferact actually kind of solves for that hardware software bridge, right? Because they can connect those two pieces together through their vLLM.
Yeah.
Yeah. Yeah, that makes sense. All right, let's do it. Scale will it scale or will it fail? Who wants to start? Go for it. You're there.
Me?
Yeah.
Okay.
Yeah,
Uh, I
you
was
raise your hand.
I just talked for a while. Uh, I think, uh, I think it's gonna scale. I mean, to a certain extent, it's already scaled, right? The software is scaled. Um, but yeah, as I was kind of saying, it's like I'm a little bit on the fence. Like the business side and what they decide to do with it and what they think the company is. Um, they have a path towards the enterprise stuff, and I think that that will be useful for smaller enterprises. Or they have the potential to like really like partner with and be funded by a major enterprise. But I think it's gonna be really, really hard for them to kinda keep up with just proprietary development for problems that they're not seeing in the open, right? There's probably a better solution to something that like, they just can't solve for it if they don't know what it is. Um, but I think kinda given the success already and what they're trying to do, and the contributors that they already have, uh, I think I think Inferact vLLM scaled. Inferact, uh, I think they will scale. I think so.
I think they'll scale. I agree to like what the exit pathway is a lot harder to predict than scaling. I think they'll scale in some nature and time, depending on how they do. It's like what path do they go? Who knows? I think they're kind of trying to tackle all paths right now. I know for the next couple of years, they'll probably find a lane that will predict their exit pathway a little bit better. Which is like, does an AWS eventually buy them? Do they IPO? Is that an option for them, and what could that look like? Yeah, it'll be interesting to see that the IPO route means that they have to continue to be really good at, at the end by end problem, right? And so that might be something that eventually gets overwhelming unless that open source community continues to grow. Demetrius, let's hear it.
Yeah, I think the verdict is they're gonna scale. However, where I'm not sure is like how fast they can scale. To what we discussed, especially in the context of selling this along or to these large enterprise players, right? It it feels like it's a natural direction, but I think it's gonna take them a while before they get there. Um, and that's where I think is a big question mark. So the way I envision the execution path on this is that the next 2 years will be very likely um, focused on building the community, building some commercialized, you know, platform that they can host a lot of these things. They also need to expand in Europe and Asia. Or like let's keep this in mind. That's not as obvious when you're building platform. And there's a lot of things you need to consider. Um, eh, and that will be the first phase, and I would probably estimate is gonna be like 2 years where this year and next year probably that's where they're gonna spend a lot of time and money that they raised to do that. Um, I don't think the 150 million is actually accidental number.
What do you mean?
So I think they were deliberately thinking about how much they need to invest in the infrastructure in next 2 years, right? They don't have that time that maybe companies that were starting building cloud solution 10 years ago, right? They know the time is in essence right here, and also the investors are probably doing their own calculation on their end. Is like, hey, what it really takes to be a winner in this category. So if you, by the way, going back to my earlier point that I made at the beginning, is that a lot of these investments around these major, large, mega funding rounds is that they investing in ideas that are in the category the winner takes all. Or at least that's how they perceive it. So so that is in line with what I'm talking about here. So the 2 years they have to build very quickly. Therefore, the 150 million is not an accident. The next phase is less dependent on them. It's more dependent on the market and how quickly the market will adopt into something that I would call out as a universal agent, right? So almost every single device will be converted into an agent, will have an agent, right? And that's what I was also referring earlier. Like you need to have experts that they know the hardware and the software in order to be effective. And I think that's where a lot of these cloud service providers will start running into the company like this one because every single device will need to process a massive amount of data. Um, and that's not something we built right now for, right? It will take time before we get there, but they will be probably well positioned at that point to tap into that trend that is coming. So um, the customers
You
are already in a space that I'm calling real time everything. That's the expectation. I'm getting impatient when Claude is thinking too long. So think about this like it's going to be a trend that will continue across the board, right? Um, I'm exaggerating, but you know what I'm saying.
well, no, I think and also, like, I think talked about this before, like, how users are using AI, like, a lot of them are using it like Google search, and Google search is really quick. Like, it is optimized, so if that's the expectation, it's a new
Yeah, but
reality
the
that
more
we're living in.
arguably more complex task you have, the longer it will take. But the expectation is still there that this is instantaneously, right? You're getting an answer right away. So I think it's just something that I would anticipate in the next couple of years. I think this company, if builds this platform fast enough, and this trend that I'm talking about will on the rise as it kind of is already, they might be surfing on the kind of very nicely on top.
So they'll scale, but they'll burn a ton of cash in the process until trends change or Google goes and builds something.
Yes,
Alright,
I
let's
think that's
do
the model. That's what
Yep.
market accepts at this point.
What do exit pathway predictions? I think AWS will buy them.
I think it's a yeah, I think it's an acquisition by someone who's very invested in them as like a platform, and Amazon is a probably like a pretty good candidate. Not only like are they using it for Rufus as it is, but they can productize it in AWS. But I mean, I don't know. LinkedIn's using it. Microsoft could productize it for Azure, but yeah, I would AWS makes sense to me. Amazon.
Yeah, I think the acquisition M&A looks more obvious at this point. But again, we don't know how this universal agent will change the landscape.
This is a
Um,
prediction. You gotta make a
so
prediction.
so I can see the path that it can be other than that, other exit than that. Um, as this will be a core element of the infrastructure that is running behind everything. Um, and scaling nicely. It's going to be almost like an imperative and must have in all these companies. Um, so yeah, that's kind of what I see is yeah, primary acquisition, potentially IPO if this trend continues.
So just maybe anything is your prediction.
Yeah, probably. I mean, it's hard to say. This is such a long play
It
that it's
is.
hard to call it.
Yeah, totally fair. Well, yeah, so we think Inferact will scale, most likely acquisition, but if you're Demetris, who knows? It'll be exciting to watch and see what they do and what the trends are, and what Google will do too. So, thank you guys for sharing your thoughts today.
Yeah, thank you.
You bet. Thank you.